Good morning.
I'm Robert. I'm the operations manager and also inspector at Scott Lunsford Pillar to Post, and I do these classes, I do marketing, and I do a lot of inspections as well. We've been super busy this season, so we're glad. I don't know how Heidi connected with your office. Heidi's one of our co-owners, but super glad that she did. This is one of my favorite things to do before I became a home inspector. Scott is my neighbor, and we were at a Christmas party at his house, and I said, hey, what's it look like to be a home inspector in my next career? And he's like, well, I want to talk to you. So that kind of evolved about 4 or 5 years ago. And just last June, a year ago June, so a little more than a year, I retired from being an elementary school principal. And so I like teaching. I don't usually teach, well, I teach adults all the time as a principal because I was always teaching my teachers. But anyway, Matt?
I'm Matt. I've been working for the Scott Lunsford team for about 2 years now, but have been playing in the sewers for about 10 years. It's sincerely my favorite thing in the whole wide world.
I pushed him down before he came into the
at the beginning of the day at least. I actually went to college for pipeline engineering under civil engineering, so I used to work for major utility contractors all over the U.S. I've gotten to investigate sewers in 47 out of 50 states, and worked for them all over for about 7 years. So this is also my favorite place to be in the whole wide world. But Robert's going to start the class here in regards to septic.
So before we start, I always like to get your voice in the room a little bit. So if you could tell me who you are, and if you either have a well or a septic story, something related to what we're doing today, that would be great if you had a situation that's kind of come up those areas.
I'm Tracy Quintana, and I am actually fairly new to the business, so
Okay.
I have not had any
No
experience
septic,
with it.
no bad septic stories yet.
Nope.
Okay.
Yet.
My name's Jill. I also don't have any experience with it, which is why I'm here.
Right, very good. Good.
I have no idea.
All right.
I'm Jess McAnally. All of mine have been fine, but sometimes you don't know what you don't know, so that's why I'm here.
Sure.
I'm Lewis. I've done a few transactions that involve septic and well, and so my motto is to learn all you can. So
Yeah.
That's a good place.
Well, and obviously you need your steam credits for re-upping your license and all that, but it's good to know the audience too that we have some completely novice around septic, because you might be surprised about how septics and wells actually work together. It might gross you out just a little bit, but it's actually totally normal, and it's actually completely a natural process of how those work together, and very similar to how your water gets filtered even by the city. So we'll talk about how those similarities come together. So we're going to learn about septics. You know who I am. You've met Matt. We've met you. Here's our team. We updated a little bit. Brian's not with us. We just hired another sewer guy. Brian moved on. And Keith is not currently with us, and we're in the process of hiring a new person in our office. That's what Keith used to do. The rest of the team is correct, other than we have a newer sewer guy and also another inspector, because we've been so busy, so we've actually added on to our team. So we're excited about that. Scott and I'll go back to that real quick. Scott and Heidi, if you saw our little sign in there, have been doing this for 20 years. They are the second oldest pillar to post in the Denver metro area. Ken Peters up in Boulder actually was the very first, and Scott started right after him. But Scott literally has trained most of the other franchise owners in the Denver metro. We will inspect basically where you need us to go. So we do see a lot of septic and wells at properties that we go to, but I will also give you a little note about that in a second. But we go all the way to basically Longmont, up to Conifer, Bailey, Castle Rock. I've been out to Kiowa, different places on the Eastern Plains, North Commerce City, out in Brighton ways, all those kind of things. So Scott and Heidi have owned the business, like I said, for 20 years. We just celebrated that this summer, and we just finished our 17,000th inspection. It's kind of funny that we're teaching this class, because one thing that we don't do is inspect septics, tanks, and wells, right? So you would want to hire, and someone always does, an actual septic and well person to come out and especially, test make sure the septic tank almost always gets pumped, right, as part of a transaction, and then also inspect it, make sure it's functioning correctly, the baffles are working right. and then also test your well water for quality and pressure and such. So, but we're going to teach about how that system works, even though we don't actually inspect those. We're going to talk about how they fail, how you need to maintain them, how to, what to encourage your clients to be doing, but obviously the septic inspector hopefully will do that as part of their report. And like you said, knowledge is great. You always want to be learning something, and the more you know, the more impressive you look to your clients. So that's always part of our goal. So let's talk about septic systems. So you have a septic system when your property is too far away for it to be hooked up to the sewer or the water lines from the utilities, right? So generally it's in rural areas. Sometimes we'll find some that are older homes that were in kind of unincorporated areas. Now they're completely surrounded by modern neighborhoods, but they still are on a septic system. It's a horse property or whatever, and they haven't converted over to the sewer lines. Most of those have switched their well over to city water, but not always. So water, and that's who would have water. It's treated if you're in the city. And this is how the city does it. Okay, so this is a great example of how things work and how your septic system actually relates to this. So normal sewer systems, everybody leads out to the main sewer, to larger sewer lines, goes to a treatment plant. Now there's a big treatment plant, I don't know what's down this direction. There's a huge one off of 270. There's in that whole industrial area there. There's, whenever we bring people to town, that's kind of the direction towards our house. And it's really kind of sad because you go past the oil refinery, the dump, and the wastewater treatment plant. So a wastewater treatment plant removes kind of the bigger stuff, gets the water in decent shape before it just puts it back into the river. It's one thing nice about living in Colorado. If you've ever lived somewhere a little further down drainage basins and you just drink the tap water, it doesn't taste as good because it's been used multiple times, right? It's kind of been processed. It's not nearly as fresh as the water up here near the mountains, especially on the north end, the west end of town. Florida water tastes terrible. I don't know. It's better now than it used to be, but when I was down there as a kid, I was always like, what is wrong with the water? But that's basically it. That's what happens. And when they remove the sludge and add some disinfectant, and it's at a level that's acceptable, they just inject that water back into the river, and then that river carries it downstream, and somewhere downstream, somebody's pulling that water back out for the use of the next community down the line. So rural wastewater, we can't hook up to the sewer, so we've got to have a different way of managing that, but it still does the same thing. The septic system is designed to get the large particulates out, the sludge basically, and get it treated enough for it to leach back into the groundwater. So that's what a septic system does, very much in the same way that the city does it. So what is it? It's an on-site treatment facility, basically, system. It is subsurface, it's under the ground, just like your sewer would be. And it basically uses the same process as we just said. So here's a nice little diagram. So what we can do, and we rarely get this, but occasionally we will have people who want us to just inspect this portion, because this is basically just like your normal lateral line, your normal sewer line coming out of your house, and we'll test it right up to the septic tank. When we're checking your lateral line, what are we checking for a normal sewer? What are we checking that length?
We're checking for all the common concerns in your standard sewer line, and we're investigating all the way to the entrance. And the first thing we're mentioning on film is we are not going to climb down in there. I don't have the right shoes for it. But yeah, we are basically still checking the complete main line from the furthest point back to the entrance to the septic tank, and we're evaluating it like we would any standard sewer line. So he's absolutely right in regards to it's the same process until we get to here. And that's when it's on a smaller scale wastewater treatment, the non-biodegradables. He'll get into that here in just a moment.
So we're going to talk about what is inside the septic tank, but basically what the septic tank is, that's kind of the catch point for the larger particulates, right? And we'll just call it debris.
It's a place.
That's where the debris stays. And then we'll take a closer look inside to see how does that happen, how does that settle, and we're allowed to get water, hopefully just water and not a lot of grease out past that. And then that water goes out into the leaching field, right? And that's where that water is then released over a large area into the ground, where it then trickles down and basically percolates through the ground, and that process itself also cleans and disinfects the water. So we'll talk more about that and its location to wells on the same site. But that's just the real kind of top level view of how a septic tank works, or a septic system I should say. So the components are the tank, we saw that, the drainage field or the leaching field, and then the distribution or drop blocks. All right. So settlement or the septic tank is for settlement of solids and also to separate out some liquids. We try on septic tanks to put less of the. We don't want to put these things down a sewer line, and Matt will talk about that later. We have a little insert about sewer lines that we're going to kind of turn loose map on that portion. But while we don't like to put grease and oils down sewer lines too much, we are going to be even more careful about that with septic tanks because it can cause some problems pretty fast. And we'll talk about the scum layer within the septic tank itself. Because we definitely don't want greases and solids out of the leaching field, because that can destroy your leaching field in that system pretty easily, and that's a major expense. All right, so you have to think this through just a little bit to really get an idea how this works. But this is a typical septic tank. Now we're going to look at a variety of kinds of septic tanks. We have concrete ones like this one here. You'll see plastic ones that are more modern. You'll see all kinds. But this, we're just trying to get an idea of what are the components and how do they work. So here comes the lateral line from the house, and then we've got this baffle. And that's a really important component because its position in the tank is how we end up separating things out. So everything comes out of the baffle and the solids settle in here, right? And then you'll notice that this baffle where the outlet is lower, all right? So those liquids are going to go out through there. Now one thing that we all hopefully learned in science, and I used to be a science teacher before I was an administrator, is that grease, fats, float. So that's another key part to this system to create this scum layer, all right? So as the wastewater comes in here, the idea is that it's gonna sit there, and the larger particulates are gonna settle at the bottom. The water is actually going to continue to flow out through this pipe because it's lower than this pipe. But we also are going to have that scum, those fats, float up above where this water entry point is. So they're going to be up on the top and not going out through the field. So we're going to see some slides a little down the way here. What happens if this scum layer gets too thick? That's where you can really run into problems and not just have a problem inside your tank, but then that becomes a problem down the line. So just a few different, like I said, concrete box kind of septic tanks. Here's a little more modern one made out of plastic materials. There's a concrete one. Just to give you an idea what they look like in real life. A few examples. All right. So once we move past there, we get out to the leaching field. We'll see some more pictures of that. But basically, it's a whole series of different kinds of tubing, often modern plastic tubing, and with all kinds of holes for that water just to kind of percolate out all over that leaching field. And then percolate down through the ground and eventually rejoin groundwater underneath the earth. And that's totally normal. In fact, this percolation process is the same process they use to clean not just the dirty water, but actually how they clean your drinking water that they're sending out through the city lines. If you've ever been to a clean water treatment plant, that's what they're doing. They bring that water in and they actually send it through these filters of different substrates that get smaller and smaller and smaller, taking out particulates. And then of course they add, the chlorine and some fluoride and those kinds of things depending on the municipality that you're in. So critical here though is we don't want our well over here, right? Our well is going to be somewhere over here, hopefully.
Garden would be good there, though.
What's that? Yeah.
Garden.
Well, that's an interesting point, and it's a great point. We actually have some pictures about that. Actually can be a sign that you have a problem when you get too much growth, because all of a sudden, when we got way too many nutrients, we've got too much water, right? Something's going on in the leaching field that could be causing us problems. So the drainage field or the leaching field is basically for the liquids and hopefully mostly water to be cleaned as it goes through. So it's a perforated kind of pipe. Pipes are buried in a gravel and then in soil, and the liquid leaks out through the soil. So there's kind of an above ground look, so the house, tank, and then out to the leaching field or drainage field. And usually it's pretty easy to spot these things unless it's kind of gotten overgrown. If you're at a home that has a septic tank and you go out back the house, you can usually find these access points. Usually there's some concrete pads or something like that, and you can find them. And then you can kind of usually see a kind of a more level space. That's where the leaching field most likely is located. There's this kind of a cutaway side view of how things should be working with all this perforated pipe going out different directions, and then the water percolating down through the soil. There's one as it's being installed, so the septic tank here, and then out to a smaller leaching field. Different example, same kind of thing, just a different kind of installation, larger system.
Is there a minimum depth that the drain pipes for the leach field have to be installed?
I don't know what the minimum depth
There
is.
is no minimum depth. The major concern would be the gravel level. You want that rock bed, you want at least 1.5 feet of rock
Gravel.
around the irrigation pipes. And that's just to remove the concern of settlement over time, but also the rocks get finer as you get down. So your first 6-inch level is going to be the finer rocks, and then they'll get a little bit medium sized, and then you're having bigger pieces of gravel right where the pipes are leaving. So that, like he was saying with the percolation process, just helps it trickle down.
Right.
And it allows the water to flow out and not soil to get in. If the
Yeah.
soil is up against it, obviously it would be clogging up the perforations. So let's go back to that. So there's, again, how the system should work. We should have the leaching field on, one end of the house. These are still kind of close together, so not to scale. But the leaching field kind of out this direction away from the house, and hopefully our well system on the other, or further away. So liquids decompose in the soil. Various, if there still are some particulates in there, they're going to get percolated out. Right, so the water's going down through the soil. I mean, it's basically just talking about the percolation process. Actually acts as a disinfecting process as well. And then it joins the groundwater. So pumping the tank, we know that needs to happen, right? No matter who's living there, at some point, even if it's not a real estate transaction, it needs to be maintained. Just like nobody does until they have a problem, your sewer line should be maintained regularly before you have a problem. And I'm just as guilty as anyone. I have a modern plastic line, but I've lived in my house for 12 years or more, and we've never had it ever. I know, it's so embarrassing. I'm so sorry. I'm so sorry. But it needs to be pumped. So we got to get that sludge out of the bottom. We got to get that scum out. We got to kind of start over every now and then. And that really has a lot of different what we're trying to say, factors as far as when and how often you want to get it pumped. So the size of the tank is one thing, and then the number of people, and then how careful are you about what kind of junk you're sending down there, right? One thing that Matt's going to talk about is flushable wipes. Well, guess what? This is flushable. But it shouldn't go down there. So, yeah, those flushable wipes are flushable, but they're really not recommended for your sewer line. They're certainly not recommended for your septic tank. So, again, how much you pump your septic tank, again, depends on how much you're doing.
Basically, your biodegradables versus your non-biodegradables, synthetic plastics, things that don't belong in the system, are going to cause erosion and decay faster, especially with older concrete tanks. They tend to have more erosion because that scum or sludge actually eats away at the original concrete walls. So even though they start pretty thick, it can break them down over time. So that's another reason why it's important to have pumps.
So a general rule is every 3 years, but again, we can break that down a little bit differently depending on the size of the tank and the number of people living in it. These are just hypothetical possibilities. If you got like about a 500-gallon tank and just 2 people, you might do it every 2.5 years. If you have 4 people, then you want to get it done every year. And a 500-gallon tank probably really is too small for most families. So,
On average, how much does it cost to pump out a tank? I'm sure it depends on how many gallons, but
yeah, I don't know what that
you know
service
what that is.
costs. Yeah, I do not know the answer to that. We don't do it, but I'm not sure what the cost of the service is. So a larger tank, a more normal tank for a family would be 1,000 gallons, and you could pump it every 6 years with it's just a couple people living in there, and again, out every 2.5 or 3 if you have a kind of a standard size family living there. Care and maintenance, again, regular pumping, regular inspection. Don't use it as a garbage disposal. Don't be putting in large chunks of food down there. Grease and oils, try to limit. And then reduce water use. So, you'll be up in the mountains and often be at a property that might be using a septic system, and they will have some notes for you about what not to put down there, and they might have special flow toilets, and just trying to reduce the amount of wastewater that you'll see very frequently. And that's just really good maintenance of any waste system, is just not putting things down there that could go in the trash can, right? Could go in a different direction. Absolutely. Talk more about that. So here's some things that can happen, right? So here's a good, healthy septic tank doing exactly what we talked about before, able to remove the water without the scum layer being too high. But once that scum layer gets too thick, or the sludge gets too thick, then it actually starts going into this outlet baffle. And as soon as that goes out, that can be a major problem. I want you to think about that for a second. So that leaching field is just perforated tubing. Once these greases and solids get in there, it really can't be cleaned, right? You can't get in there and figure out how to clean those little holes out that are now all clogged up. You basically have to tear it out and put in new piping, and maybe, depending on how bad it's gotten, you might be redoing the entire field as well, as far as the gravel and everything, depending on how much sludge and grease has gotten into the field itself. So Matt's going to tell the exact same thing about sewers, about things that you don't want to put in a septic tank. You really shouldn't be putting in your sewer line as well. Oh, and one of the biggies, and it's also true for sewer lines, is really be careful about the chemicals that you put in there. And one of my friends that's an HVAC guy brought this to my attention. I hadn't really even thought about it, but on high efficiency furnaces, they're creating condensation, and the condensation actually is a bit acidic. And if you've put a high efficiency furnace in an older home that has cast iron, there really ought to be a neutralizer also placed on there so that it's neutralizing the water before it goes down in your cast iron, because it actually can start to corrode that away. So chemicals, even when you're kind of not thinking you're putting chemicals in, your line really can affect your line and your septic tank. Okay, care of the drainage field. We don't want to actually plant gardens and shrubs and such on it. It seems like that might be a great source, right? We don't want, obviously, roots and such. We want to keep it out. So it's deep enough that we don't have root intrusion, and we're not putting things in there that actually have deeper roots, like trees and shrubs. Runoff water, we don't want it necessarily to be catching a lot of runoff water that's also then percolating down. It's just going to oversaturate that area. And then obviously we don't want to be driving over top of it as well, because it isn't that deep, and you can actually break lines. And Matt will talk even about crushed sewer lines in brand new houses, which happens too because people are construction traffic's driving over it. So tank replacement might be too small for the family, or it might be damaged, an older one. More modern materials are lasting longer, hopefully. But you can have older systems that start to break down. Those concrete guys, have a lifespan before they start to do so. And then, any components can be fixed, not necessarily have to replace the entire system. For example, the baffles.
Do you know about when they started going to the plastic ones?
Started using plastic regularly towards the end of the 80s.
Okay.
Yeah, the plastic drain lines were and septic tanks usage was possible in 1965. The two guys that invented it kept it their little secret for a few years, tested the system, and then it became public use about 1988.
Okay.
Wow. Somebody actually tested something before they put it out in the field?
You see here now, they created it and said, hey.
Oh, you lining lines all over the place? Leaky. Again, replacing a drainage field can be quite costly. The soil may no longer absorb. You may be replacing everything from the gravel to the soil underneath, the soil on top. It could be very expensive. Crushed pipes would be a reason you have to replace it. And then just again, if you need a larger volume, if you're replacing the tank because you have a larger family, you're probably going to need to replace the field as well. Okay, some warning signs that something has gone wrong. Water on the surface, wet spots, and then could be clogging back up into the house. Oh no.
Jeez.
That's cute. I thought I had some pictures, but I guess I took those out. But we had some pictures of basically all of a sudden your leaching field is too green, it's too wet. Those are signs that something's not working right. This is Matt's friend.
Sweet.
You actually found this guy.
I met him in Littleton. He was shy to be on film at first. I had to motivate him and coerce him out to actually make the film. But that's now my business card. I really like him. He's going to be quite a few times. And that's what I do. I investigate sewer lines. I don't just inspect them. I create educational documentaries of sewer lines. And what I kind of wanted to talk about today was just some simple things to look out for during a sewer inspection, not just a pillar to post one, but any sewer inspector. You kind of want to make sure that they're on top of what they're doing and not feeding you a sewer. So, jumping right into it, first thing I look for is the age of the home. Typically anything before 1985 is going to have original material. So it's always recommended to just speak with the listing agent about their sewer maintenance. You know, do your sellers actually have it cleaned? When's the last time they told you they've had it cleaned? Because 9 times out of 10, if they don't have it cleaned, I can't do my job, which hurts my heart. I like to investigate sewers, and I can't do that if they've never been serviced. So that's one thing to consider. And even in newer sewer lines, it's important to have them serviced as well. Just depending on the material will depend on how often that cleaning should occur. But what I want to talk about more so is what the inspectors actually tell you on site. Now, when you're dealing with the inspection/repair company, 9 times out of 10 you need a repair, which is really bizarre, you'd think, because electricians aren't allowed to do that. You know, HVAC guys aren't allowed to do that. And sewers, I feel, is a little unregulated. So I'm going to jump right into tree roots growing in the sewer line. We all have heard this. Is it bad? Is it acceptable? It just depends on the material. Some material are allowed to have tree roots growing into them. Some of these sites might look a little disturbing, but I promise they're just tree roots, not human debris. Okay? That's a polite way to say it. But that's what we're looking at here is buildup from tree roots growing into a sewer line. So looking at this, an inspector could tell you this needs to be repaired, but I know a guy. Not necessarily the case. The way that they connect older materials with flexible joints were made to shift over time due to the possibility of expansive soil. So that way they're introducing the possibility of tree roots. Having them growing in from the top of the pipe or the sidewalls, completely acceptable. Because one thing I do test for is dissipation, meaning I'm making sure that water's not escaping the sewer line throughout, and that's something we'll get into here in a minute. But it's important to know different materials are allowed to have tree roots growing into them, and some are not allowed to have tree roots growing into them. And these are things that you want to ask the inspector. So outside the home, seeing a vitrified clay pipe, BCP if you want to be technical, completely fine. Concrete sewer lines, similar situation, completely acceptable to have tree roots. Those also were made with shiftable joints or flexible joints.
Now when you say it's acceptable,
Meaning,
you don't mean you want them in there,
Oh,
but it means that your line isn't necessarily damaged.
Thank you. It means that it's still being functional. It doesn't mean that it's broken or there's a concern. It just means that they've wiggled as they were supposed to and allowed the introduction. So seeing that, completely acceptable. And then just going over it really simply, at the joiner connection, yes, that's okay. That's where they grow in. In the middle of the sewer line, that's when we have a problem. That's when we find an issue. And typically, it's very obvious when you have a hole separation, or what we call a void, because there's just no pipe there. And seeing that in between the connections would be a concern. Now, clay sewer lines coming with a 3, 5, or 8 foot lengths of pipe. I don't need you guys to know that, but I need your sewer inspector to know that. I want you to be able to ask them questions. How long are these clay sewer lines? How long between connections? And the more response you could get from your sewer inspector, the more I would assume you could trust them. And so that's important to me, is being able to explain what they're seeing. You know, when you have a home inspector and they give you the rundown at the end of the inspection, it seems very smooth. They're not using too many technical terms to mislead or confuse you. They're explaining what they're dealing with and what they detailed. I want the sewer inspector to be able to do the same thing for you as well. Once again, tree roots growing into the clay eventually become a problem. This is when it becomes a problem, when it's lack of maintenance for years and years and years. And the ceiling ring or joint there has been pushed out of the way by the root system at this point, meaning it's just a major lack of maintenance, gotten very far out of control. One of my favorite things about clay, though, and I am a member of NCPI, that's National Clay Pipe Institute. Promise it's a real thing.
You just made that up.
I should have.
You're the president.
When they break down,
The president.
when these clay sewer lines break down, they don't have to dig them out. It doesn't become a hassle. It's clay. There's clay in our soils. It's completely fine to leave it in the ground. When plastic pipes break, we have to dig them. When he was talking about new construction, I was at a job in Wheat Ridge in the Applewood neighborhood, in a $1.5 million home, and 15 feet down at the foundation, they had a crushed sewer pipe. They had to excavate 30 feet out. Cost them over 10 grand. It was disrupting the neighbor's property that they just bought on the same. So, is it important to investigate sewer lines? Every single one of them, whether it's a brand new build or an 1800s home.
We had a brand new build that I was on the inspection. I
Yeah.
wasn't doing the sewer because I don't do that.
I don't blame you.
And you know, modern system, they put in two different accesses outside, one that goes in and sweeps into the house, one that goes down and sweeps out towards the sewer. They had put both in going, I don't remember if it was towards the house or away from the house, but both going the same direction, and
Yeah.
they wouldn't know that had our not investigated it. So.
Right, and that could be a couple grand just to add those access points or correct them. So yeah, it's important to do your due diligence in regards to sewers, in my opinion, personally. And then your original cast iron underneath the home. This is 85 and older homes. You're going to see original cast iron. What I normally look for is scaling and fog. Fog in the sewers? Alright, this is a little bit of fun. It's fats, oils, and grease, okay? That's what we call it. And when I talk sewers with buyers, I do it with a smile. I do it without any profanities. I'm never disgruntled. But I do it in a way to educate, inform, and do it so they can actually enjoy learning about their sewer system. But he's absolutely right about non-biodegradables. Those harsher industrial strength chemicals. Anything saying on the packaging industrial strength ultra degreaser, or products even such as liquid plumber and Drano, those are actually bogus products. And what they do is they heat up with a little oxidation and they remove the hair that collects on this fog, the fats, oils, and grease. And so 2 to 3 months later, you have another backup. Pour more chemicals down there. I think they work alongside the cast iron companies, I really do. So normally at my house, if I do have a backup or blockage, I reach for Dawn dish soap, because that's really good at removing fats, oils, and grease, and it's very low on the chemical scale. And like I said, throughout my talking here, I'm just going to mention little bits and tips and tricks that I provide for buyers that I hope that other sewer inspectors do as well, because I do believe it's important to educate and inform rather than just look down the sewer line and say it's good, it's bad, have a nice day. Let's get into this. Now, this is a plastic sewer line that I found tree roots growing into, and plastic is one of the pipes that you're not allowed to see tree roots in. So cast iron, not acceptable for tree roots, and plastic, not acceptable for tree roots. The way that they connect these plastic sewer pipes, it's a very overly abundantly secure connection process, is a polite way to say it. And they do this so that way tree roots will never grow into there. So when we see them in a plastic line, when we see them in a cast iron line that we know is threaded or tightly secured, we immediately call it a failure. We don't want dissipation. We don't want water escaping. And that's one thing that I feel is lacking in the sewer inspection industry is dissipation testing. At every joint, every connection, every turn in the sewer line, we run very minimal amount of water. So that way we're watching, is it pooling at the connection? Is it traveling down the line, or is it being drained down? Because we are not on a septic system halfway through the lateral, and we don't want it leaching out into your yard. You know, what if you do have a tomato garden? But this is just a reference to the plastic connection. It's called a bell spigot connection. They take the last 4 inches of one length of pipe and will sleeve it into there. There's one compression fitted gasket in there. On the outside, there's another 3-inch rubber gasket. Basically, I've said too much, but it is an overly abundantly secure connection process. So whenever you see tree roots in plastic, it is an immediate failure. Now, the dissipation testing. What concerns me is if I go to a property, it's an older home, it's a 60s home, and I can't inspect the sewer line because there's tree roots, massive amounts, and it's blocking my equipment from going through. I get to say it's time for a cleaning and reinspection. But what I try to provide for buyers is, since I didn't get to finish the inspection, I want them to send me a video of what the sellers provide, so that way I could help them, walk them through it, help them, teach them, and help them understand what they're looking at. And what I see a lot of in these re-inspect films is they're running the bathtub full blast, and then they're running the sink full blast, and they're skipping things like this. There's been plenty of times where I just did one with Robert, 65 Forest, where I called for a cleaning re-inspection. I noted that there was damage in the line, but I wanted to finish the inspection before any repairs were made. Different sewer company came out, I'm not referencing names, and they ran water full blast, and they didn't see any of that dissipation, and they said, everything's fine, we don't know what the original inspector was talking about, he's crazy. So I went back out and made a very long-winded documentation of the dissipation, and found damage on the secondary line as well. So when your sewer inspectors were running water full blast, they're skipping half the inspection, I feel. And so it's important to make sure to pay attention a little bit when they're inspecting the line, when they're creating the film. You know, not only are they informative in explaining everything to you, but are they running mass amounts of water, which is skipping situations like this that can occur. Or like this, very slight, but we have a fracture running all the way down the channel of the pipe. Now, if I was running water full blast, it would look like a sewer line. But since I was very minimal amount of water, I was able to see it escape at this point, and I got to call it out as a need for repair. We don't want pooling of water in our yard. It's really just not recommended. Not one of my favorite things. Once again, if water was running full blast, we would skip the void. Now, the other part of my inspecting is called a pitch flow grading test. And it's real simple math. Basically, in a 4-inch diameter pipe with a 2-inch camera head, I watch 1.6 gallons of water rush by. In doing so, I'm testing for velocity, volume, and how long it takes to dissipate. Right. In other words, I flush a toilet, okay? I flush a toilet, all right? I flush a toilet once, and I watch it travel by. But it's important to have minimal water running, especially when situations like this occur, because you can just jump straight over it if you're just learning how to move a camera. But the pitch flow grading test helps me with this portion of the test. Is it too much of a slope? Is it too minimal of a slope? Too minimal, water and material implied there is going to collect. Too fast of a slope, and only water is going to travel, material is going to be left behind. We're calling this material.
Are those meatballs?
Those are meatballs. I think they're stained cotton balls.
Brown cotton balls.
I will never be able to eat meatballs
But this is why the pitch flow grading test is important as well. I want you guys, if you're dealing with the sewer inspector in the future, to ask them, do you measure the slope? Do you measure the pitch? Some will tell you they're reading the high water mark, which is just where the discoloration is, about halfway up. But you hope that they don't say, no, we just run water and look for obvious signs of damage. That's what you don't want to see. Also, there's bends and turns in the main sewer line outside the home. I explain this on every film. That bends and turns in the sewer line are reducers or restrictors. So even if we have proper pitch or slope, if it ran straight for too long a length of pipe, water would gain too much momentum, and then we would have leftover cotton balls. So we don't want that to happen. And then there's certain materials that are immediate failures. This one is called Orangeburg. It was made by a construction company out of Albany, New York in the 1950s. And they said, you know, we're making really good money in masonry, but we have all these leftover materials, let's create sewer lines. So they basically took tar and cardboard and said, we're going to call this a sewer line. And that's what we're looking at, is some compressed cardboard with tar on the inside. They can never be cleaned. They can never be serviced. And if you attempted to, you would just break it up into line. So you're going to see it in homes from 1950 to 1960. It's not very common. I've been doing it about 10 years, and I've only seen a handful of them, but they do exist, especially in older Denver.
How is this called exactly? Like, how do they call this material?
They call it tar paper material, but Orangeburg is the reference.
Yeah,
So
that's what I'm.
Orangeburg, orange as in the fruit, and then B-U-R-G.
Wow.
Fun stuff. And I make friends in the sewer world. It's part of what I do. Making friends with the buyers, agents, making sure they understand completely what I'm saying. I typically make about a 10-minute documentary, and in that documentary I'm discussing how often cleaning should occur based on what material is used. Once again, I reference questions to ask to make sure they're hiring the right sewer cleaner. So I don't say, oh, use this company, they're the best. I give them the knowledge and tools, kind of like a home inspector is going to do with the house. I'm just trying to educate, give them knowledge and tools to make sure they're hiring the right person.
But you do know the right people, right?
Oh, I do, but that's my secret. I never tell them. I don't want to be associated with any other company. I just want to give them information. It's kind of like learning how to mow the lawn. You have to get out there and push, right? No pressure. No pressure. But, no, sincerely, sewers have been my passion for a long time, and making sure your sewer inspector is not running water full blast, making sure they understand that pitch is important, and also turns in the line, where tree roots are acceptable and where they're not. These are some of the most common occurrences that I'm seeing being misdiagnosed in other people's sewer inspection reports. So I just want to make sure you guys were hiring the right person when it does come time for an
Camera
inspection.
size matters, right?
Camera size is a factor. It is, 2-inch camera is recommended. The 1-inch camera is sitting at the channel or base of the pipe, so you're not seeing as much as you could with a 2-inch camera, and all of our inspectors run a 2-inch camera.
What's your take on bellies? Like, what's okay?
So some of those are acceptable. This one is, for now. I'm working on it. I'm working on it. It's all those biodegradables. No, some standing bodies of water are acceptable. There are ways to measure them. Once again, that pitch flow grading test is a really great way to do that. You know, that's based on the theory of 2 gallons per minute. Another one is actually reading the sewer line, that high water mark. If before the standing body of water, it's at the top of the pipe, that's a strong indication that it's created backups, right? So knowing how to read a sewer line is going to help you when the investigator says you have a little standing body of water. It lasts for about 6 inches long, and it's about a ½ inch tall, and you're looking at that high water mark saying that it's at 50%, and he's saying we could replace this for you really quick. It'd be about $4,000, and we'll take care of it. You know, you could say, hey, I see what you're saying there. I do wash my hands from me. I see what you're saying there, and no, everything is completely acceptable. So there are some that last for 20 feet long. Those are going to be a conflict. And it just depends on measuring it. And so communication with your sewer inspector, making sure they understand what they're dealing with, and do reference how often cleaning should occur and what method of cleaning is recommended. Making sure they're educated on what they're doing, and they're not just basically pushing a camera forward and back with a lot of water running. It is important to me because you don't want your buyers to come back 3 years later and say, well, now we got $10,000 in sewer repairs.
Yeah.
So that's kind of that's it for sewers. Thank you guys for sitting through that. Lightly filled stomach. You guys are brave. I appreciate that.
All right, on to cleaner things. Wells. So wells are obviously taking water from the earth, and sometimes, you know, it's really very clean water, especially if you're up in the mountains. I mean, most well systems are also going to have filtration systems and such attached to them. But we're basically just going to kind of cover the basics of the well. So you got to get down below the water table, obviously. If you're going to have a well, that could be very shallow. It could be pretty darn deep, depending on where you are. And it really isn't necessarily, well, I'm in the mountains, so it's going to be really deep. And you know, in Colorado, it's just deep or whatever. Frequently, you've seen this hopefully, in homes you'll see sump pumps in brand new houses in regular neighborhoods here that are running the water out of those sump pumps, you know, on a regular basis because the water table is high just in that area, and that's just a regular neighborhood. So water tables really just depend on where the natural water is flowing underneath the ground. So it could be a long, deep dig, hundreds of feet, or it could be pretty shallow. Well types, a dug well is basically like you would see on Little House on the Prairie, right? Just a big old large well, stones on the outside of it going down. A bored well is a similar kind of thing. We have a big old auger that would dig out the well, not usually as deep. Most wells nowadays are drilled, especially here in Colorado, a drilled well of a much thinner pipe down to the water table. Again, there's information about what a dug well would look like. We're definitely much more old school. A bored well using a large boring kind of machine. And it can be deeper than a dug well, and then a drilled well, which is usually about a 6-inch diameter well going down significantly deep drills. So a basic well system, you're going to have some sort of piping, could be concrete sections going on down to the water table. We're going to have a submersible pump, and we'll talk a little bit, very little, about the physics of pushing water as opposed to trying to suck water out. But submersible wells are the standard, submersible pumps are the standard for wells. And then we just got to get down to the water table. And then obviously it's important to keep the cap in place, and we'll talk about that because we do not want anything getting in to contaminate our wells. Alright, so drilled well construction, again a well cap on top, and then our piping going into the house, our submersible pump at the bottom. Obviously we have an electrical supply going down to the pump, and these things obviously need maintenance. Everything has a lifespan, right? Sometimes you need to replace your pump, or you could have issues with the piping, but less likely with that or the electrical cable. I think we went to. Quality is important, right? So during the transaction, definitely have your client get the well water quality tested. So a good well person will come out and they'll test the quality of the water as it comes out of the well. If there's filtration systems, they'll check the filtration, they'll check the water quality coming out of the tap. Again, we don't do well testing. We do have clients that occasionally just have us do some tap water testing, whether it's a well system or just a city system. They want to know what's in the lines. Whether we test for heavy metals like lead, we test for particulates, and we test for bacteria as well.
No uranium, you don't test for that?
We're not looking for uranium. That doesn't come back, right? We do test for radon in basements, but no, we're not looking for uranium in the water necessarily. Avoid surface water. So obviously surface water is still dirty, right? It hasn't gone through that percolation process all the way down to the groundwater. So we don't want surface water entering the well, and we obviously don't want to be taking surface water as drinking water. I was at well, actually, I'll go back to that slide. I was at an inspection up in the Conifer area, and a huge, beautiful home, and they had moved the well. I don't know if this one had dried up or whatever, but they had added an additional well, about 50 yards this direction from the original well. But the cap on the original well was off and just laying open. That's not okay, right? And while I'm not a well inspector, I certainly saw that as I walked past it and made a note that, hey, this needs to be fixed because we are introducing contamination to groundwater, or at least a possible source of contamination to the groundwater. So we want to keep that cap in place. So you can still get contaminants, right? You can still have septic systems that aren't being completely filtered out, contamination of impurities in the soil, depending on the minerals that are in the soil and such. You may have harder water, so just different contaminants. You can have pollution from mining, from all kinds of things, and so water quality again always needs to be tested regularly for bacteria, for various chemicals, fertilizers, another good example of things that can get into your water. So these are all things, just like the septic system, when you're working in a well system, you want to be careful about your environment. What are you adding out there, right? Are you putting bug spraying, weed sprays, and those kinds of things to your environment that could eventually percolate down into the groundwater, and especially if that groundwater is really not that deep in the first place, we certainly can contaminate it much more easily. So getting water to the house, as water collects down below, you got to pump it up to the house. And you see a variety of systems, and we'll see a couple of pictures here of more modern systems. But it's easier, like I said, to push water to a house than it is to pull it with a above ground pump. So if you have a less than 25 feet, you can put the pump inside the house. Water is drawn by suction, but once you get past that 25-foot limit, it starts to become pretty difficult. It's very much the same process. You can't get a straw that's like 3 feet long and still suck out of the soda. It just doesn't work that way because of air pressures. So there's a typical above ground kind of pump with your motor and tank attached. Deeper wells, we're going to actually, it's easier mechanically to push the water up than it is to suck the water up, and again, that's what we typically see. And a submersible pump is really pretty small little gadget. It's just a little turbine down there that gets that water moving and pushes it up through the system, and then the well is refilling beneath it. Pressure tanks. So again, you're going to see a variety of kinds of things. If you go into a basement, you're like, wow, what's this giant cistern sitting over here? Well, that's a water supply, right? So if your well isn't filling so fast that you can just get on-demand water from it, you're probably going to have an actual tank in the house that's keeping water available on demand right there. And how are we going to get that to move through the house? What causes the pressure to push it through the house is usually a pressure tank. So there's an air pump and it's pressurizing the tank to push the water through. What gives you water pressure in the city system? Typically. Anybody know?
Just the water pressure itself.
Mm-hmm. Why does the water come into your house? What's pushing that in there?
The main water line.
Right, but how does it get pressurized? Anybody know? Typically just gravity. It's gravity fed, right? Where do you see water tanks? Or water towers? You see them up on hills, right? And so it's just getting pressure from being up on a hill. When you're not up on a hill, you get your water tank sitting in your basement. It's not just going to naturally come flowing to the second floor. So you've got to either have a pump that's always pumping it there, or a pump that's filling a pressure tank to actually supply pressure to the rest of your house. And so
Are there any guidelines where it's safe to have a well and where it's not? Let's say there are areas very close to landfills.
Sure.
There are areas very close to mining
Yes.
waste.
And while I'm not familiar with all of those are certainly things that would have to be tested and are regulated, yes. That
So
are
do
places
they
that may not
test do they really test for really nasty chemicals or?
Yeah, I mean, a good well person will certainly test for the quality of the water and all those things that you're kind of
Now,
talking
is
about.
the solution is to get the water from deeper levels, or there is?
Well, you definitely want to make sure it's coming from the groundwater, because the groundwater is going to be the cleanest when you get down to whatever that water table is. Not necessarily deeper into the groundwater itself, but once you get down to that water table, that's the cleanest it's going to get. Yeah, it's just a matter of testing, and I'm sure there are some areas, and this has nothing to do with water tables, but you've brought up uranium, I'll bring up plutonium.
Yeah, those
so,
kind of things.
we got rocky
Nobody's
flats
talking
out
about
there.
anymore, right?
We're starting to build all over that area.
Right.
It's very close to Rocky Flats, and I live close to Rocky Flats, but not like on top of it. But I mean, those people are signing waivers that they won't garden. I mean, I'm not going to live in a place where I can't garden, right? Because of the possibility of plutonium and such in the soil. So that's an example of, there could be very specific areas, whether it's around mining or something like an old weapons plant, that you'd want to know more about what's going on.
Well, Southeast Aurora has very, the soil has sulfur, lots of it. So when people have wells, they are in trouble. The water stink, pretty much stink. They have to yellow and stink.
Right.
Yeah.
Yep, sulfur will do that. So you can have contamination. That's certainly one of the problems that you can have in wells. Sometimes it won't be supplying the water fast enough. Again, that's when you have a tank up top. But your well could get dry, especially during dry periods. You might need to dig a new well to a deeper area, and I'm assuming that's what happened in the inspection that I was talking about, where they had a whole separate well.
Well, talking about the pump not being fast, or not pump, but I guess the supply not being fast enough. When we get it tested, I mean, typically I've got my well guy that comes out and says, well, it's pumping it, 12 gallons.
Flow.
Or whatever, the flow.
Yeah.
So if that's low, you're going to see the cistern inside, and that's gonna have a pump, and you probably wouldn't notice then if that was really low.
So that's one way of dealing with it, right, is to continually have that pump pumping into that. So I was doing a new build out kind of north of the airport, but it was far enough out that it was on a well system.
Okay.
And yeah, there were, I don't know if it was one or two, but there were, like 1,000-gallon
Yeah.
tanks in
Yeah.
the basement where that water was stored. The well guy was actually there testing at the same time. If I had had more time, I would have gone and talked to him just about what he was doing. But he was testing the water outside, he was testing the water inside. But that's the whole idea, is if you can't supply it fast enough, generally speaking, you're in Colorado, you're going to have a tank up top.
So if you get a report saying that it was pumping at 12 gallons or whatever, they're talking about at the well, they're not talking about out of the cistern or whatever, right? I mean,
Correct.
Okay.
Right.
Okay.
Right. Yeah. Now, I mean, they might just flow within the house as well, but yes, if they're just talking
Okay.
about how much is being supplied by the well,
Okay.
yeah, that would be the flow rate there.
okay.
Inlet could be another thing, it's just out of adjustment, the system needs adjustment. So contamination could be from surface water, storm water, septic tanks, all kinds of places. Water has an odor, if it's got sulfur in it, if it's got other contaminants. So those things can happen and need to be monitored. And they can happen in the city system, right? How often do you hear like a news story where something went wrong and all of a sudden they're saying, hey, flush out your system for a half an hour before you use it or whatever. When we had that flooding event in 2013, if you lived here in 2013, one of my daughters was up at Greeley. Actually, she lived just a little bit south of Greeley in Evans, I think. And they couldn't use the toilets or the water for days because the system had basically overwhelmed itself and had contaminated both systems. So they were told, don't flush any toilets. And she came home. Don't flush any toilets, don't run any water. And then, they got the system back online. They had to run their water for a certain amount of time before they could actually drink it again. So again, problems with water, you may not be supplying it fast enough, especially during particular high use times of the day. So well runs dry, that can happen, where you have to put it in a different spot just because we've gone through a really drought kind of period, and I'm sure that has happened to people in past years, and all of a sudden their well's working great this year because we've had so much water. So that can happen. Pump failure, that's going to be normal, right? I mean, I have this complaint right now about an oven that's not working for some inspection we did like 6 months ago, and I'm like, I can't promise you that it was working 6 months ago, but it is part of our, inspection that we turn it on, make sure it warms up, turn it off. Things do break. Believe it or not, they're broken in the last 6 months.
Just recommend the home warranty, that's it.
Yeah.
Right, yeah, exactly. So components can fail, right, in any system. Pressure tank failure, so again, pressure, I think I have some more pictures coming up here of all these different components, but and again, the system may need adjustment. It could be short cycling. It might not be holding enough pressure to send it throughout the house, just like any other mechanical system. So that's just a quick summary of wells. Again, we don't really do the well system, but just to give you an idea of how those two components work together, septic and wells in more rural environments. I think I took out some of those pictures just because we added Matt in, that's why. So, yeah, anyway, that's a quick version of wells and septic tanks. Hopefully that helps you a little
So
bit.
one question going back
Yeah,
to
please.
septics, because there's microorganisms in the septic tank that are helping
Or breaking
break
it down. Yep.
So as a detrimental, do you have to use certain kinds of soap, like biodegradable soap, or like pouring bleach into the system?
You want to avoid bleach, right? There are things you want to avoid to that aren't killing those microorganisms, and then there are additives that you can put in that encourage those, right? I'm trying to think of one of the names of that product. Ridex, right? Yeah.
So good enzyme cleaners are really good for septic systems. Whenever I am inspecting a sewer line leading to a septic system, I recommend a Ridex, a good enzyme cleaner, because they don't mess with those little bacterias, the good probiotic bacteria that breaks things down. Those enzymes are actually a natural way to clean and remove some of the scum level from the home. Not all of it, but it helps maintain it. And yeah, bleach is one of the things. Heavy ply toilet paper, there's a big list. Flushable wipes, baby wipes, feminine hygiene products, dental floss, toothbrush, toothpaste, cotton balls, and Q-tips. I could keep going. There are certain things that you don't want going into a septic tank, though, absolutely.
Right, and the biological factor that you're talking about within a septic tank is critical to the way that it breaks down. It works the same way in a fish tank. If you've ever had a fish tank that didn't have like an external filter, it's got that gravel bed and it's got a kind of a little filter system underneath. Basically, when you first start a fish tank, you put some starter fish in there to get that bacteria filter working before you just add in all too many fish, because it helps to break down those nitrates and such that are in the water.
But regular dish soap, like you say,
Regular
stuff
dish
is
soap
fine.
should be fine in that system, yeah.
You don't have to use special soap.
And you said don't use what, Drano and what?
Liquid plumber, Drano, the harsh chemical cleaners, yeah, that's why I generally recommend Dawn dish soap for backups and blockages. But for septic systems, there are once a month tablets you can drop into your toilet, like Rid-X or Green Gobbler. There are different brands. The most specific thing is just a good enzyme cleaner is what I generally recommend people with septic tanks, because they do help those probiotics or good bacteria to help do their job and stay alive.
Okay, great.
So on the table, be sure to grab a few of our materials. We do have a pamphlet about our different inspections. This is a really nice guide, this larger one, that agents often give to their clients. Like if you have a buyer's packet, it's just a nice thing for them to be able to look at about how much is the cost of fixing is in the home. So they're walking through a house with you in 1970s, it's barely been updated. They're like, how much is it going to cost to change the kitchen out? Is it 20 grand? Is it 30 grand? What is it? So it's some guidelines around flooring and basically every component in the home, replacement and repairs. And then just some goodies right there if you need some pens, chapstick. Those little microfiber wipes are really nice too. And grab some other snacks because it's really easier for you to eat it than for me to take it home.
So do you guys work just as a team, or do I call you just for a sewer inspection? I mean, how does that work?
So Matt
I'm gonna
and
call Matt for sure inspection.
Matt and Anthony and Todd are our sewer inspectors. They are employed by us. We're on the same team. So we provide, so you call our number to set up an inspection. We'll set up your inspection, we'll set up your radon testing, we'll set up your mold testing if you want it, and we'll hook up your sewer inspection as well.
So, but like if I only needed a sewer
Sure,
inspection?
we can do that too.
It doesn't matter?
Yep, we do individual things as well. So if you need a sewer inspection, if you need radon separately, we do all that kind of stuff.
Okay.
Yep, we can pretty much offer you whatever you want. You guys run into all kinds of situations, right?
Yeah.
Where somebody's like, I just want the mold tested.
Yeah.
Everything, leave it alone otherwise. I just don't need to know if there's mold. We can absolutely do that.
How
Yeah.
do you test mold, by the way?
So we have a couple of different ways. If there's nothing obvious, and we do air samples for mold, and so we can test those. A general mold test would basically take 4 samples, 1 outside to get a background level, and then 3 different areas in the house. For example, if it's a 2-story, we'll do the upper level, the main level, and the basement. If it's a little smaller than that, we'll try to pick out the areas that are more likely. If we see
How much that will cost?
the mold testing is a little more. It's like $300 because
But air
it
testing.
ships out to a lab and right. So it's
Air
about
testing
300.
about 300?
Pardon?
Air testing would be 300.
Yes. For
That's
air
like
testing.
you're very inexpensive.
Oh, good. Yeah, it's like 320 or something like that. And then we can also, if there are spots that we see actual mold that somebody wants tested, we can swab that so that it can be taken into the lab just to find out exactly what kind of mold is there, and that it is mold for sure. Sometimes it can just be some weird stain, but so there's swab testing that we can do as well. Generally, people, as they see a new home, if they have sensitivities to mold, we do the air sampling as kind of a starting point, and then we try to get that done ahead of time. So as we're going to the actual inspection, and we've got some higher levels, then we know to be looking. If we have a weird water leak in the crawl space, in the subfloor, wherever, be kind of searching for it a little harder even.
Did you do math testing? No.
So we can provide clients with the kit to do that. We usually it's free. Let me try that again. The kit is free. We can get those from our lab, and then they do it to actually do full meth testing. There's like a certification or licensure that you need, but we have some that clients can do and then send into the lab and have a process. And we do get that is becoming more common.
More common, unfortunately,
yeah. Especially again if you have
Unfortunately,
sensitivity.
right?
Yeah. Very good. Well, thank you guys.
If this was any good, this is perhaps not my favorite class. It's
my favorite class.
We have a whole list of classes that I left with Paul. Structure, foundations, old houses, new houses, asbestos. One of the favorite ones that I do that a lot of people like to hear about are grow houses, and we do see quite a few of those where people have kind of made a mess of the house because of
Yeah, you have good slides on that one. I've been to one of your classes.
yeah, so we got some good ones on that. Anyway, thanks for having us
Great,
today.
thank you very much.
Very much.
And take your
Oh, thank you.
certificate for your CE and get that.